Thank you, Sivia. Hello, everyone. Hope you're doing well. I'm Drew, and appreciate you joining our Cloud Security Masterclass, where we're all about putting engineers in command of cloud security. If you've attended a previous Masterclass session, it's great to have you back. And if this is your first time, welcome. We're thrilled to have you. Today, we're going to be digging into serverless security again, this time taking a closer look at identity and access management services, or IAM, and how hackers can exploit IAM misconfigurations in your serverless environment. First, got a few announcements. Next Thursday, Corey Quinn is joining us for a special masterclass session, Screaming at Security. If you don't know who Corey is, I mean, who doesn't know who Corey is? It's Screaming at in the Cloud podcast, Last Week in AWS newsletter, Quinny Pig on Twitter. Expect this to be a very lively and fun session loaded with a lot of snark, but also valuable insights for how you can better manage your cloud and security. So join us for that. And in December, we've got a session where we're going to be taking a look at pen testing your cloud infrastructure environment. Pen testing, as we all know, is a critical component of any security program. I think few realize that cloud misconfiguration attack vectors rarely play a role in pen testing efforts, and they really need to be. So join us for that, and we'll help you kind of think about how to start incorporating cloud infrastructure in your pen testing, how to evaluate vendors for whether they really know what they're doing when it comes to cloud misconfiguration attacks. We have a growing library of masterclass sessions available on demand, so access those at fugue.co/masterclass. And if you haven't downloaded your free copy of the Engineer's Handbook on Cloud Security, make sure you go do that right after this session. That is at fugue.co/handbook. All right, we got those out of the way. Chat is now open. If you have any questions or comments at any time during the session, please do pop those into chat. Make sure that you direct those to everyone as well as panelists, so everybody can kind of be a part of the conversation, and we'll make sure that those get addressed. And with that out of the way, let's go around the horn, make sure we've got everybody on. First, we've got Wayne Crissman, Director of Security here at Fugue. Wayne, you there?
Hey, everyone.
Hey. Next, we've got Curtis Myzie, our VP of Engineering here at Fugue, and the guy that's led the effort to build out Fugue's serverless product, software as a service product around cloud security. Hey, Curtis.
Hey there.
And to kick things off, we've got co-founder and CTO at Fugue, Josh Stella. Hey, Josh.
Hey, Drew. Hi, Curtis. Hi, Wayne. Hi, everyone who's come and joined us today.
Yep.
I'll take it from here, Drew. Thank you.
Yep.
So a little bit on what masterclasses are. What we're trying to do is to share with you ways to think about problem spaces. So the one we're focused on today is around serverless computing, and in particular, how IAM forms a network. We cannot tell you everything we know about this in an hour, and we don't know everything about this. So what we can try to do is show you how we think about these problems so that you can solve your own problems and elevate the things that are of the highest priority and most importance. All right, if you've been at, well, let me see, can you raise your hand if you've been to any of our master classes? Okay, it looks like we've got some folks who have, but many haven't. So we try to do something fun. You can go ahead and put your hands down. Thank you. We try to do something fun with these, and we try to keep them real interactive. Okay, so you know, I'm going to keep an eye on chat the whole time, says Sivia and Drew. You know, fire off comments. Let's have a little bit of fun. And one of the ways that we like to have fun is giving away swag to folks who are attending. And the way this works is probably 4 times. Sometimes we do 3, sometimes we do 5. It depends on how it goes. I'm going to replace my background with a Zoom background. I was going to say Slack background, a Zoom background that is something from like nerd culture. And the way I define nerd culture is stuff I like. So I hope there's a lot of overlap, but it's going to be like history of computing. It's going to be video games, science fiction, anime, stuff like that. Now, the way it works is I'll put up a background, and the first person to name what the image is from. So if it's a you know, TV show or a movie or an anime, you just name the movie or the anime or the TV show. If it's a computer, you name the computer. And if it's a game, you name the game. The first person to do that, yeah, we're doing Wayne's World here. That's right. Exactly. So the first person to do that is going to win a swag pack from us at Fugue. You'll get a really cool shirt and some other neat stuff. So I'm going to go ahead now and put the first one up, and then we'll start diving in, just because it's fun to do these. Okay. Let's start with a video game. Anyone know what this video game is? This is highly relevant this week. Anybody? Nope, nope, not Grand Theft Auto. It is not. You're probably in the ballpark though. It just released this week on the new Xbox Series X and S. It's a long series. This is the latest chapter. All right, I'm gonna take that as I picked something a little, not Watch Dogs. I'm gonna try something else here. Oh, Dale got it. Dale got it. It is Yakuza. And that's what I was up till midnight doing last night. Okay, let's get on with some business. If you didn't win that one, there'll be other ones, maybe things you're more familiar with. Right on. Okay, so the agenda, I'm going to set the table a bit on serverless security and IAM. I'm going to try to give you, with a whiteboard session and a couple slides, a mental model for how to think about this, okay? How to break down what is a very complex problem into some kind of fundamental models that you can work with in your own environment. All right, and then we're going to go into a deep dive, and I'm very pleased to say, I often do these. Today, Curtis has put together an absolutely awesome deep dive on IAM. And then Curtis, and no pressure, Curtis. And Curtis and Wayne and I are then going to have some conversation around things like recommendations and what we had there. And I really hope that you all jump in to that conversation through the chat as well. It's just more fun that way. Okay. A little bit of set. I promise, not too many slides. I think we have a total of 7 slides, including the end. So bear with me. We're gonna get to more fun stuff. So we really need to rethink security in a serverless world. Like, a lot of how we've thought about security in the past has been things like operating system security. Oh, and I'm reminded here, I'm watching the chat go by, I'm reminded, if you win a swag pack, don't guess at the other images, because you can only win once per masterclass. But if you keep coming back, you can win one this one, one the next one. But if you win one, don't guess anymore, because that can ruin it for everybody. Okay, so in traditional security, in data center security, we really thought a lot about operating systems and networks. Right, a lot of our segmentation was done through things like access control lists at the network layer on, subnets or IP address ranges, and we thought a lot about, vulnerabilities of the operating systems that were running on the compute instances and things like that. This is really different in serverless, because in serverless, you're not really thinking about the operating system. You can't even see the operating system. And the network is typically not defined by TCP/IP network address spaces. The network is actually defined using identity and access management. And that is a network in this kind of use case. So with serverless, you're kind of right in the deep end of the new security models in cloud, which are all about cloud API configuration and misconfiguration. Okay, that is the new attack surface. And if you're serverless, it's almost, it is very much the new attack surface. Okay, it's not the only one, but it's the biggest one. All right, so a lot of these misconfiguration vulnerabilities are not seen by compliance standards like NIST or CIS or GDPR or HIPAA or anything as actual problems, and that is a problem. Those standards have been around for a while. They're trying to address this, but they move kind of slow. And what we see all the time at Fugue, you know, we do cloud security and compliance all day, every day. It's what we do for a living. It's what I was doing when I was at AWS before co-founding Fugue. What we see is over and over again, folks are trusting things like CIS and NIST to tell them everything they need to know. But a lot of the things that real world hackers are doing are not really captured by those. So we like to recreate those hacks and build real additional coverage to let you know if how hackers are doing this in the real world through misconfiguration of APIs applies to your environment, if you're safe from those. So because they're often not recognized as vulnerabilities by tools, they're often not recognized as vulnerabilities by the security teams who use those tools, right? So, and they are only really fully apparent in the full context of the environment. So we're really pleased. We just announced a big partnership today with Sonatype, where we do pre-flight checking of things like HCL, Terraform templates. You can catch some there, quite a bit actually, but you also need to be running checking misconfigurations in the running environment. You really need the whole life cycle. So therefore, the audits and the security teams often overlook these or just don't know about them. And we discover new ones all the time. The best way to know what you need to secure against is read the details of hacks, because that's going to tell you, right? And so we do a lot of that. And therefore, these misconfigurations are very common in serverless environments and cloud environments in general, okay? And they are often exploitable without detection. So it's common to see breaches occur, the Uber breach, the Capital One breach. The only time these companies learned about the breaches is when the hackers bragged on social media or extorted them for money. So it can be really hard to catch these things because we tend to not be looking in the right place. Okay. I want to talk a little about the shared responsibility model, and also why serverless takes some stuff that was on the customer's plate and puts it on the cloud provider. And by the way, you want that as much as possible. You want as little responsibility in the shared security model as you can get. You want to offload this to AWS or Azure or whomever. I can tell you they're extraordinarily good at it. I've spent a multi-decade career bouncing between national security kinds of things and high-tech companies and startups. And having worked at AWS, I absolutely trust that they do this extremely well. It's much harder for businesses who aren't in the business of doing cloud computing as their lifeblood to get it as right. So what we always do at Fugue is, and we recommend to our customers, try to push as much responsibility onto AWS or Microsoft as you can. And serverless really helps that. So up here at the top, well, let's talk about the bottom first. You've got, the actual hardware, physical plant, compute, storage, database, networking, and software that is helping you manage all of that. That's what it says here. And then above it, in the customer side, are operating system, network, and firewall configurations. Okay, well, do we have to do operating system configuration much anymore? Not so much. Not so much, because the operating system in AWS Lambda, for example, we're not really directly interfacing with the operating system. And we're going to be using more IAM than TCP/IP networks. All right, I'm being a little long-winded, so I'm going to we're 18 minutes in, Curtis. I'm going to run about 4 or 5 minutes longer than I said. I'm sorry, but I will promise to leave you plenty of time. So I'm going to stop sharing my screen. All right. We'll do, come on, PowerPoint, get out of full screen, please. Thank you. We will do another background, and then I'm going to whiteboard a bit, and then I'm going to turn it over to Curtis, who's actually going to do some real, like, live hacking. Let's see. I'm not sharing my screen, so you won't see when I'm choosing my background, I hope. All right, how about something from computing history? What is this computer? I can't do my Vanna White, it's not picking up. It's not a Lisa, but you're real close. The Lisa was the predecessor to the Macintosh. This was the spiritual TDC 2000. No, it's not an Apple product. It's not a Commodore product. It's not a company who makes computers anymore, but they were in the inventors of Ethernet, of graphical user interfaces, of object-oriented programming. Just astonishingly, it's not Sun Microsystems. I love Sun Microsystems. All right, Brian. Well, okay. Civia's going to have to decide. Brian came in first and said Xerox, but JT said Xerox Alto, and that we did say that the computer. So I'm going to leave it to the judges, of whom I am not one, to decide that winner. Okay. Let's get rid of the background, and we will do a little bit of whiteboarding. And I just want to get you thinking again, like a mental model. Oh, Civia gave it to both of you. Civia feeling generous today. Okay.
No one wants to be a bad guy today.
Yeah. Awesome. All right, she's in a good mood today. Right on, Civia. Okay, are you seeing my screen and my scribbling on it?
Yep.
Okay, cool. So I want to talk here, and if you've been to these before, I've done this before. I'm going to go quick here because we need to give Curtis some time. But I want you to think about 3 kinds of things in the cloud, because these are how you have to analyze policy and security in the cloud. So one, and I'm going to use the Amazon names. There are principals. Principals are things like users. Call this one Joe. Okay, they're actors. They are, now they can also be things like Lambda functions, right? Or EC2 compute instances. And we're going to be talking a lot about those kinds of use cases today. All right, so you've got principals who are actors, and then you have actions, which are things like S3 list or EC2 describe, things like this. These are the verbs of the cloud, the actions, and there are a lot of them. Yes, Joe is a hunchback. I'm not drawing that well today, Brian. Joe is a little bit of a hunchback, but he's awesome anyway. All right, so we've got actions, we've got principals who are actors, we have actions, and then we have resources, okay? And I mentioned these are, and resources are things like Lambda functions, EC2 instances, S3 buckets, etc. But they're the specific ones, okay? Now, does anyone know what the default policy in AWS is for being able to use actions or get to resources? There's a default policy. Yep, Savannah got it. It's deny. Deny everything. I don't mean that like in a court of law. I just mean deny all of those action accesses and deny all of the actions and principals to the resources by default. So what we're doing when we're creating IAM policies and other types of policies in AWS, and is very, very similar in very similar in other clouds, it's just slightly different terminology, is we're just poking holes, right? We're poking holes through these things. Now, what we're going to be talking about today is more down here, than my man Joe. We're going to be talking about things like Lambdas being on both sides. Okay, so this diagram is a little tough that way, but let's say we want this Lambda to be able to execute what's in this other Lambda. We'll call this one B and we'll call this one A. Now imagine a graph of these where you're trying to be least permissive and make a system work. That's really why I think of, and we think of IAM as a network, because effectively that's a network. You are limiting access and you're opening access. Okay, I ran 4 minutes long. I said I would run 4 minutes long. Sorry, Curtis. I'm going to turn it over to Curtis to do a deep dive here. So I'll stop sharing and I'll hand the mic to you, Curtis.
No problem. All right. I will share my screen. All right, you should see the viz, right, Josh?
Yes, indeed.
All righty. So what I'm going to share with you is this example serverless application in AWS. It's pretty small, just a handful of resources, but despite its small size, it's got some big vulnerabilities. So this is deployed with CloudFormation, and I'll just kind of give an overview of some of the resources in here, and then we will drill down into some of the Lambda code and into some of the vulnerabilities that this has. So some of the resources we've got here, we've got a network containing an RDS database. This happens to be the new Aurora serverless RDS database. We've got the VPC containing that, some subnets, security groups, 2 Lambda functions. One of those is inside the VPC, one of those is outside the VPC. You can do it either way. An EC2 instance, which we aren't going to focus on today, and an S3 bucket. So data storage in this application is split across the RDS database and the S3 bucket. And kind of the context for this application, or the gist of what it's meant to do, is that we're managing an online forum. So the entities in this application are users, posts, and comments. And the information for all that is split across RDS and S3. Kind of out of scope for this demo, normally we'd have like an API gateway or load balancers involved, and perhaps a REST API, and that's how the application would interact with this backend. Today, we're just keeping it more simple, and we're just going straight to these Lambda functions. As you probably know, Lambdas can be behind an API gateway or a load balancer and build a REST API in that way. But like I said, we'll just directly invoke the Lambdas today. One of these Lambdas over here is actually in good shape. He doesn't have very many issues. The other one though, this one called app user posts, has several vulnerabilities, and we'll be taking advantage of about 3 of those. And at the end of the day, what this set of vulnerabilities is going to allow is for us to actually take that Lambda's credentials and use them in whatever way we want. So I will show you how we go about that. So all that said, I will switch my screen. All right, so we've got VS Code here. All right, so this is a Git repository. It has all the code and configuration for that application. To briefly run through that, as I mentioned, we're using CloudFormation to deploy, so we split up those resources across a handful of templates. We've got the 2 Lambda functions have their source code under app and app user posts. App user posts, like I said, is going to be the one we drill into. And so let's go ahead and do that. So app.py, this is the core code for the Lambda with vulnerabilities. So I'll give a brief overview of kind of the purpose of this Lambda, what it's supposed to do, and then we'll get to talking about where it's falling short, where some of the deficiencies are. All right, so written in Python, as you can see, less than 100 lines of code, pretty simple. And a lot of this is okay, but there's a few key lines where this really opens some glaring holes. All right, so this handler function is called when the Lambda is invoked. Like I said, that could be from an HTTP request as from the app or a direct invocation from somewhere else. We're gonna let the user who's making the request pick a sort order for the results, whether it's ascending sort, descending sort. We're gonna query the RDS database to retrieve some records. This in particular, we're retrieving posts associated with each user. We're gonna summarize that data, kind of massage it a bit, and then we're gonna respond to all that in JSON back to the user. So it's pretty simple. Won't get too into the query for now. One interesting thing to call out is that this is using the Rds Data Api, which is a way for Lambdas to make SQL queries on an RDS database without actually having direct network access. It's instead using basically the IAM network to do SQL queries on the database directly. So kind of there we're seeing that, you don't even have to be inside the same VPC as a database to necessarily, expose vulnerabilities on the information. All right, so back to the handler. Let's drill into this summarize user post function. So this is basically just aggregating or summarizing some information about that user in those posts, and that information is returned back in the response. For whatever reason, the developer here is shelling out to a shell script in the Lambda, which is a bit atypical, but not out of the ordinary really, in that, maybe you've got legacy scripts or something like that, and you need to rely on those, even though you're executing in a Lambda environment. So we're going to build the shell command. We're going to run it in a sub-process and decode the output. Pretty simple. We're going to summarize information for a user given their email address. And so the shell command is pretty much, execute this shell script with the email address as an input. So herein lies one of the first vulnerabilities we're going to take advantage of. This application separately had a deficiency, which is users were able to change their email address to a non-sanitized value. So the attacker in this case is actually including shell commands in their email address. And given that, when these emails are retrieved from the database and passed in here, we're actually going to be injecting shell commands here to be executed in the Lambda environment. So that's a key OS command injection type vulnerability, which has been around forever, but now we're taking advantage of it within a Lambda function. All right, so that's a little bit about what's going on. I'll open up a terminal here. And just to make an example request, I've got some scripts here. We'll make a request, and this is like making an HTTP request. Like I said, you can imagine we're using curl or something like that instead if you want. And we get back some JSON, just like you'd expect. All's well and good. Here's the thing though. So this attacker has learned of this vulnerability somehow, and they've set their email address to have a shell command in it. And so what is that going to allow them to do? So if we look at the full response to that request, and then let's direct it to a file. What are we going to get back? All right, so here's the response from the application. A bunch of information about users and posts, which mostly is fine, until we get to some information from the one user who intentionally injected shell commands into their email address. They've injected the env command, which retrieves environment variables. So now this response from the API has the entire set of environment variables contained in that Lambda environment. And so the attacker can then parse that. And if I turn on word wrapping, you can kind of get a gist. It's a whole lot of stuff in there. Much of this, interestingly, are environment variables that AWS injects for you on your behalf. And the application developer isn't in control of all of these. And if we just kind of search through that, you can see that that includes an AWS secret access key, AWS access key ID, and a session token. This was not any bad programming on the developer's part in this respect. These are variables that are in every Lambda invocation that allow that Lambda to then use IAM to access other resources like Josh was talking about. So now the attacker, we've got a script just for this, which just parses some of that information out. And let me see. So we'll run that. Oh, I'm missing. Gotta run it with Python in this case. All right, so this script just parsed out that JSON blob and looked for the important environment variables. These are the three ones we're focused in on. AWS access key ID and secret access key, you've probably seen those are pretty commonly used when you're developing applications. AWS security tokens, a little less well known, I would say. This is a temporary token that provides temporary access. So all three of these together let you assume a role in AWS, and then you have whatever permissions that role gives you. So now as the attacker, we can copy that, actually set those things in our environment. So we've got those three environment variables set now. We can call AWS get caller identity as the attacker. So now we're executing, we're running scripts on my laptop, but now I have the role of the Lambda function, and I have those credentials locally. So I can do whatever that Lambda is able to do now. And now, as an attacker, perhaps you don't know what the permissions are, but you can start to kind of get a sense for that. And I can execute any AWS CLI command and listing my S3 buckets, for example, or listing, this company's S3 buckets. So I can get a bucket name. And then from there, we probably have a script on hand to start extracting documents from that bucket. So we can run that, start stealing some documents. And now, that bucket's leaking information out. And, again, we're using credentials that were really given to that Lambda, but you can see that they're actually usable anywhere, not just on the Lambda. Those credentials are valid anywhere. So an attacker can make use of that. And so, yeah, we're in pretty bad shape here. If we look back at that Lambda's configuration, here's where we set it up in CloudFormation. So app user posts, that's the Lambda we're working with. You give each Lambda a role, and so we can trace down that role. The Lambda role has a few different AWS managed policies assigned to it, and then one additional inline policy. And a key thing here is this role has full access to S3. So as an attacker now, I can do pretty much whatever I want on these S3 buckets, assuming those buckets don't then have policies that block my actions. So as the attacker, I can even delete objects from the bucket potentially, or replace objects, any number of other actions. So we're in a pretty bad spot here. Quite possibly this permission was broader than what that Lambda actually needed. And so that's a key deficiency here, on top of the obvious deficiencies in having the OS shell command injection vulnerability. The IAM permissions here are also too broad. So that is kind of a quick tour of how you can, leverage a deficiency in a Lambda to potentially gain access to IAM permissions associated with that resource. And then those IAM credentials are fundamentally usable from anywhere. It doesn't matter if you're in Lambda or not. So that's a quick overview of this exploit. There are actually other ones in this Lambda that we probably don't have time to get into, but this is actually also susceptible to a SQL injection attack. I will switch back to the viz.
Hey, Curtis,
So,
we have a question from Balaji. I hope I got your name right. Is the security token the same as the session token?
that's about how I understand it, yes. And
yeah, me too. I think the STS service can issue those session tokens to other services. So.
Yep, that sounds right. And that would actually be a good thing for me to learn more about because I'm actually fuzzy on the distinction myself. But yeah, I believe when I was looking at it, the Lambda did not have a session token. It only had that secret token. All right, so let's see. Yeah, you all can see the visualization again. So yeah, just a quick recap, so we're exploiting a vulnerability in that Lambda. In this setup, I've actually written a custom rule in Vue to highlight a deficiency in this Lambda, which is called out here with the red icon. And that down there in the bottom left, you can probably see, or may be able to see, this Lambda should not have full access to S3. So we're calling that out. So that's one key deficiency that, can be highlighted at the configuration as code level, because we have deficiencies both in the configuration of the Lambda and in the source code of the Lambda.
Awesome.
And,
yeah. And that gets back to like, what resources do you need access to? Right. A lot of folks put star in the resources when they're granting. So this is the, S3 list action or S3 read or S3 write actions. There's a bunch of them. Well, you probably don't need any one Lambda to see everything you have in S3, which is the resource star. So you want to restrict in some way to keep that hole you're poking to resources as small as it should be. There are different ways to do that, like attribute-based access controls, rather than just, or you can list resources in your IAM policy. That can create a lot of like code maintenance issues over time.
And to briefly drill into that, yeah, as Josh mentioned, like removing this and having a more fine-grained policy would have gone a long way in this case. Another thing which we haven't really gotten into yet is the possibility for assuming roles cross account or invoking Lambdas across account. And for all that configuration, you're going to have the option to be, as fine-grained or as broad with permissions as you want. And so you can see here on this role, it's just a quick illustration of some of the different options. So this role is going to allow somebody from this account to assume it. And then one of the key options in here is, do we restrict that to using this external ID field? That's one of the key security features with assume role. And then similarly, like Josh mentioned, whether or not you have a star for your resource, or whether you lock that down to, the ARN of some particular resource, that makes a big difference. Similarly, on your actions that you define, if you lock it down to one or a specific list of actions, that's ideal. As soon as you start adding star, your attack surface or your number of vulnerabilities is increasing quite significantly too.
Oh boy, is that true. The other problem a lot of folks don't think about with star on IAM policies for actions is that AWS add actions over time. So if you star the current form, so example on EC2, 4 or 5 years ago, you could not change the IAM role of an EC2 instance while it was running. Well, they added that feature. And if you had star selected, all of a sudden, you had opened up every principal with that star permission to do something extraordinarily dangerous. And you might not have noticed that happening. So please don't use stars. So we got another question here. I'm going to route these. Curtis, Wayne, take your pick, or I can answer if you want me to. Does this vulnerability have a similar analog for Fargate tasks that accept command overrides from a REST API?
Yeah, I believe it's exactly the same situation. And that's another case where Fargate, you're still serverless, but there, perhaps you're even more likely to have, scripts, binaries, libraries in that container. And certainly, that service could have similar SQL injection or OS shell vulnerabilities that let them take advantage of the same thing. And that container running in Fargate is going to have an assigned IAM role in exactly the same way.
I would also add to that too. If you are running something in Fargate or ECS, you may give it something like star permissions or broad permissions on ECR, the container repository. And if you do something like that, there's an opportunity for an attacker to publish a bad image that has something like a backdoor exploit or something that will stick around even after you find the SQL injection vulnerability and patch that, fix it. And then you've still got this bad apple sitting there ready to rot the rest of your service every time you deploy it.
Yeah, I mean, agree. Of course, you're both right. I agree with everything you said because you're correct. But what I want the attendees to think about here is going back to that shared responsibility model and the desire to offload responsibility, right? This is undifferentiated heavy lifting. Security is, if you sell cars, you need a secure computing environment, but security is not driving revenue. It's a means to an end, and it's kind of what we call at Amazon undifferentiated heavy lifting. So you want to shove as much of that onto Amazon as you can. EC2 for compute has probably the most responsibility on the customer, followed by a container has more has less than an EC2 instance, right? There's more of it being handled by the provider, and a Lambda has even less. So our application is mostly Lambda based, and it's really nice because when we went through Wayne, Wayne, why don't you tell the story? You were the guy who was interfacing with the SOC 2 audit.
Sure. So yeah, so like Josh said, we're towards the tail end of a SOC 2 audit now, and it was really nice when we were able to cut down days worth of interviews into a day when we got to sections like, what is your patch schedule like for your compute instances? Well, we don't have that here. So we were able to just sort of sidestep entire classes of problems that just NA right down the board, and focus on, other things that we would have to deal with anyway, in addition to running our own servers, and in addition to running our own servers. So we got to focus entirely on those things and shove the rest towards AWS.
Yeah, it's really fun to tell an auditor who asks you, how do you patch your operating systems, to say, we don't have operating systems. All right, I'm going to do a background. Curtis, thank you so much for that. And Wayne as well. But let's do another background, and then we'll go back to the slide deck and do a little Q&A. Where did my window go? Choose virtual background. There we go. All right. I'm going to do an anime. So name the anime this thing is from. It's not Doom. Nope, this is an anime, not a game. It's not Outlaw Star. It's not Gunbuster. You gotta go way back. Yeah, Nikita. Nikita got it. It is from Akira, which if you haven't seen, you should go see because it's awesome. All right, I'm gonna go back to no background. I'm gonna pull up the last of our slides, and then the three of us are gonna have a little bit of a conversation that you are welcome to participate in. Okay? Oh, Sylvia said, Oliver, I need to stop naming winners because I always miss something, and Sylvia's got to clean up my mess behind me. So I'm sorry, but is what it is. Okay, unless Sylvia decides to be generous again. All right, I'm going to share screen. Let's go this screen. All right, and on current slide. Okay, I want to get a full screen for. Oh, now I got it. Thank you. Okay, now we've got the right screen and some recommendations. So I would like, you know, Wayne, can you start with this first recommendation about least privilege, or if you think Curtis should answer that one, you know, kick it to him. But
Sure. I mean, I think you covered it right at the beginning when we were talking about IAM being a firewall, principles, actions, and resources. And you want to keep the holes that you poke in those firewalls as small as you possibly can. And that's what least privilege is about. You want to define the smallest amount of actions required on the smallest number of resources required for the Lambda to do its job. And one sort of a code smell for this would be if you are finding that the holes, you're having to give permissions like star. Like, oh, I need access to 100 buckets, so I'm just going to do star. That might be a Lambda function that should be broken down a little bit. That would be my kind of takeaway from the first one. Curtis, if you have something to add there.
No, you got it. And I think like a quick little scenario, I think, you know, highlights this really easily. Say you've got a project, you've got one Lambda or one service, you know, there's a set of permissions it needs. Maybe they're pretty small at first. You add a second Lambda, say, and you're like, you know, it'd be quick just to reuse the same IAM role, has the same responsibility more or less, or it has similar needs for permissions. That's true today, but then, you know, fast forward months down the road, somebody else is in that code base. They need to add permissions to the first Lambda, the first service. They add S3 full access or whatever. And now that, you know, unknown to them or accidentally, they've granted way wider permissions to not just the thing they were looking at, but also other Lambdas, other services that happen to reuse that role.
yeah, those are excellent points. And I would add that when you use this pattern, you are going to proliferate the IAM roles, right? You're going to end up managing more of those. And so that's something to get your hands around and find a rational way to do that. It's not a terribly hard problem, but it's one you know you're going to have if you use this pattern, which you absolutely should. All right, some of these are pretty clear. You know, be careful with cross-account IAM. Be super careful with cross-account IAM. It should be very restricted in terms of where you're using that.
Yeah, and to kind of build on that, it's interesting to me that, you know, you can have, like Josh said, hundreds or maybe even thousands of roles your team is managing. And the difference between being completely safe and having a huge gaping hole is literally one character sometimes. Like if there is that asterisk in any role, that's a big problem. And so, you know, the smallest of mistakes can have big consequences, I guess.
Yeah, this is not about a product pitch, but this is part of what we do for a living. Is you can point to, you saw the visualization at an AWS account or an Azure account, and we're going to look for all those things, and we're going to tell you over time if they show up later, because it's really hard to get the signal out of the noise when you're operating at scale on cloud. Sorry, Wayne, I think I cut you off. You had something to say.
No, that's quite all right. I was going to say for cross account, I would go so far as to say just don't do it unless you have a really, really good reason for it. I would say just avoid it altogether.
So that's our director of security speaking. So yes, I'm just gonna agree with that, because he is our deepest expert on these things. Okay, on operating in a secure way. Yeah, delete Lambdas you're no longer using. Delete everything you're no longer using. Don't leave anything in your cloud account, including snapshots. Often snapshots have stuff like old keys in them if you're not doing IAM the right way and you're embedding keys. But everything sitting out there that you're not actively using and monitoring and paying close attention to and you need is attack surface. And these are internet-facing APIs for the most part. And bad guys, the hackers, are really good at finding stuff that is either stale and out of patches, if you're running things with operating systems, or is just misconfigured a little bit, as Curtis showed. Curtis, why don't I let you roll through the next couple few of these, and Wayne and I can jump in.
Yeah. So the minimized dependencies one is interesting. I mean, it's one of the advantages of Lambda in a way. You know, it's a small application. Hopefully it has minimal responsibility, and consequently you can get by with very few libraries, if any. So that's a great thing to strive for when you can. The next one, using the Lambda execution environment. So I think if you're not deeply experienced with Lambda, one of the interesting things you learn is that, you know, a single Lambda environment, or effectively a Lambda container behind the scenes, it's reused for multiple requests over time. And, you know, that has a lifetime to it. So that Lambda execution environment might be around for 5 minutes, 10 minutes, an hour. And that could end up processing hundreds or thousands of requests potentially. And if due to a bug in your code in that Lambda, or maybe intentional caching, you know, you've got potentially information that's available, you know, that's created in one request available to the next. And that could be a real vulnerability, especially if you know that one Lambda is processing information relating to multiple users or multiple tenants. Then this aspect of Lambda execution you actually do really need to be aware of and careful with.
Hey, Curtis, sorry, I'm just checking time. We got 5 minutes.
Yep.
I want to make sure we get to the end of the content we've prepared in the next 5 minutes. We're happy to hang around for a while if folks want to hang around, but why don't we just pick out anything that's, you know, we've got the text up here. If there's particular points you or Wayne have on these before I move to the next slide.
Well, I would say, Wayne, chime in on WAFs real quick.
Yeah, so what Curtis was showing earlier, what Curtis was showing earlier about these Lambdas would be behind an API, you know, recommend using something like a WAF or something that's going to inspect user input for things like SQL injection or OS command injections. These are the kinds of things that WAF was designed for and is super useful for.
Hey, Wayne, would you recommend using the WAF service, or like standing up a WAF in EC2 or something like that?
So, I mean, to keep with our serverless motto, we would go WAF service. I mean, you might find that it's not good enough for you. That's completely up to you as running your business. But again, it does push more stuff over to AWS, where you're talking about just configuration at this point versus patching and upkeep and things like that.
Yeah.
In the latest AWS WAF functionality, especially with their like out-of-the-box CloudFormation template that they have, it's really quite sophisticated and quite nice. So I'd encourage anybody to take a look at that.
Very much agree. All right, let's go to our key takeaways slide. Yeah, so I'm going to take the first one and then open it up. We got 4 minutes. Serverless security is deeply architectural. It is very much about building stuff the right way and understanding the problem space and the vulnerabilities that exist and getting it right and keeping it right, as opposed to monitoring flows of data. That can help you, but it's only going to help you too late. What you really need to do with serverless security is get those configurations right up front and understand what you're exposing and to whom. Wayne, what about taking us through a couple of these bullets here after the first one?
Sure. Really, the first two are kind of about that the old stuff is still relevant. You know, we're using all kinds of great new tools, serverless RDS, Lambda. We talked a little bit about Fargate, but you can still be vulnerable to number one on the top 10, right? Which is SQL injection. You can still be vulnerable to that. So all of that stuff is still relevant. But you're getting into the next point. You now have new stuff you have to think about. IAM as a network is not something that we're really familiar with, like Josh talked about. You know, we're used to tripping network alarms on packets leaving the network, but in everything that you just saw, The only real detection you can do on that is that you would see, you might get a guard duty finding on, hey, there's a weird IP address doing a listing on your S3 buckets, you should check that out. But you're not going to trip any network alarms on copying data out of an S3 bucket, for example. Lambda is being reused across multiple requests. That's something Curtis was touching on. In the previous slide, we talked about not storing user data because you may end up using the same Lambda session across invocations. So that's something to keep in mind. There may be some kind of data spillage there. It's something you should control for and be aware of.
You know, I'm sorry, Wayne, let me jump in for a second on that.
Sure.
This is kind of a bigger issue than just with serverless and Lambda that I'd like to recommend as a cloud software architect myself. You really want to isolate computation from persisting data. That becomes way more important in the cloud. And they called it Lambda for a reason. These don't always run as Lambdas, right? An anonymous function. But the way I think you should think about these, both from a practical perspective as building functionality, but from a security perspective, is don't store anything in these guys if you can help it. They are pure operations, they're pure functions, and handle your persistence another way. Sorry to interrupt.
No, it's quite all right. And then we talk about things like VPC can give you a foothold, same with EC2 instances. Don't take like Curtis showed in his setup, just because a Lambda is not attached to a VPC, which is something we recommend not doing unless you really need to. It's still possible to be vulnerable to an attack against a database, like we saw, because AWS has an API for running direct SQL queries, for example. Compliance may not help you with serverless security. That's totally true. There's very little compliance around IAM. That's a lot about what we do, like Josh has been talking about.
Yeah. I mean, yeah, we are a tool for helping you learn this stuff. These classes are not pitches, but that is what we do, and you can try us out for free. All right, I'm going to go to the last slide here for a second, but I'm going to do one more background on the way out. We're right at the top of the hour. Those of you who hung in the whole time, which is the vast majority of you, get one more shot at some cool swag. So I'm going to stop sharing. And what do you guys want? Something like a science fiction, or do you want a game, or do you want history of computing? First person to say something in the chat. Sci-fi. Okay, you get some sci-fi. Here. I didn't have some. All right. How about this one? That's going back in the day, but that's some sci-fi. Lost in Space. Yes, indeed. Yes, indeed. The original Lost in Space, when I was a kid in rural Wisconsin, it was a high point of my week. All right. Any other questions for us? Otherwise, I'm going to turn it back over to Drew and reshare my screen with that slide. Any other questions?
I was going to say, Josh, that's like one of the first backgrounds that I got. I used to love that show.
Yeah.
Yeah. Get any last minute questions that you have in right now. Otherwise, thank you for joining. Sivia had posted a link earlier. Sivia, post that again if you can. Wanted to let everybody know tomorrow Josh is speaking at the AWS Community Day at 1:30 p.m. Eastern time, and he's going to be focused on S3 security. Really kind of taking a deep dive into making sure that you properly secure your S3 buckets. So that'll be a lot of fun, and it's free. So you should go check that out.
Okay, I'm sorry, Drew, let me jump in real quick because we got a question here. Any security scanners that could pick these up? Why, yes, in fact, there is one, and it's our product. Which is free forever at small scale, a pure SaaS, and of course we have big enterprise customers who pay us money at scale, like SAP and AT&T and Red Ventures. But you can try Fugue out for free. Just point it at your account. we're going to visualize the whole thing and paint stuff red that we think is a dangerous configuration. And we baked it just a ton, hundreds and hundreds of rules into it that will help you with that. We do a bunch of other stuff too, but this isn't a pitch. But yeah, we are a security scanner that will detect these things. Sorry, back to you, Drew.
Yeah, and we do a couple things that might be interested for anybody that wants to learn a little bit more about Fugue. One is we do some public demos. So if you want to kind of come and check out Fugue outside of like a one-on-one engagement, we do those every 2 weeks, as well as our one of our senior solutions architects, Ricardo Green, and I lead a Fugue office hours, which are roughly about every 2 weeks that we live stream on YouTube. And each session kind of takes a little bit of a deep dive into using Fugue for a specific use case. It might be something around bringing your cloud into compliance, detecting change and getting alerted on dangerous misconfigurations that might occur in your environment, shifting left, all sorts of different kind of use cases that you can accomplish with Fugue. And that's on our YouTube channel. And you can find all of this as well in our resources section on our website. So a lot of resources there to learn more about Fugue, as well as some of our more educational resources like the master classes. Definitely, please do come out next week and check out the session with Corey Quinn. Josh, I know that's going to be a.
Oh, he's going to give me such a hard time, and it's going to be so much fun.
Yeah, you've had fun with him on his Screaming in the Cloud podcast, so it'll be awesome to host him here and get his thoughts on security, because I know he focuses primarily on not wasting a bunch of money on AWS.
That's true, but he is a cloud expert.
Absolutely, yeah, and he's
phenomenally bright and really understands this stuff. So I'm really excited about it. I think it's going to be a blast.
He's known occasionally for having an opinion or two.
Occasionally.
Yeah. So maybe we'll we'll work hard to pry some kind of opinion out of him during that session, but it's going to be a ton of fun.
7 seconds.
Right. So if we don't have any other questions out there, we will call this one a wrap. I want to thank you, Curtis, so much for putting together this awesome simulation of a serverless hack. That was great. And Wayne, thanks for joining us. Always great to have you imparting your security and compliance wisdom on these.
Thank you all.
And Josh, whiteboard. Awesome work.
I like whiteboarding, man. All right. Thanks, everybody. We'll see you next time. And